And welcome back. It is the 19th of May, further maths 5 a day, and let's just go straight to the first one. Right, so first question is to factorise fully. Now the word fully is quite important here because the word fully implies there's at least 2 or 3 steps going on, which I can see here already because I've got x's, y's, z's and 15s and 20s. Let's start with a number. So both numbers divide by 5. The lowest common power of the x's is x. The lowest common power of the y's is y cubed. And the lowest common power of the z's is z. Then see what I need to multiply by to get back to these terms. So to get back to 15x y cubed z, actually it's just 3, isn't it? I'm just going to multiply this by 3 because I have the y cubed z x on the outside. This one's a bit trickier. So 20 divided by 5 is 4. X squared divided by x is x. Y cubed divided by y, or y4 divided by y cubed is y. And the z is the same. And that's it. I have factorised fully. Next question. Okay, so this one says by drawing. This is one of these that I know students and pupils tend not to like. The key point is it has given me a graph. And then what it wants me to do is it wants me to solve this thing by using the graph I have. In other words, I need to transform this, the whole thing, into something that has this within it, because I know what that looks like. So if I do it, it may make a bit more sense. So I'm going to start with x squared minus 2x minus 1 equals 0. Now, the x squared is the x squared, so I'm going to write x squared. The minus 2x I want to be minus x, so therefore I need to add x to both sides in order to make it the thing that I want, which you'll remember is this thing down here. Similarly, the minus 1 I need to be minus 2, so I'm going to take away 1 from both sides, which gives me minus 1, minus 1. I have the graph of this, I want the graph of this, and then I need to see where they meet, which is my x values, where it happens. Let's very carefully draw the graph of y equals x minus 1. So it's going to look something like this. Now, in an exam, this is the whole point of the question. So as accurate as you can, try and draw. So you can see I'm going slowly to try and get this broadly correct. Try and draw the x values, or find the x values where these lines meet. And that is going to be x is equal to minus 0.4 or plus 2.4. And that is going to be my answer. Next question. Calculate just annoys me a bit. Calculate the gradient to the graph of this at the point here. Right, now, I'm pausing because I suspect it wants me to use the graph. So it would normally say in an exam using the graph, and you would have to show you doing it on the graph. So I'm going to assume that's what the question wants, but I'll do it both ways. So I think this is broadly, and actually it feels a bit exact one, doesn't it? I'm thinking about it, and that does make sense, and I'll say why I've said that in a second. So I've got 2 points as far away as I can, A and B. So A is the point 0, minus 3. And B is the point, well, I go across 4 and I go 1. So therefore the gradient from here is going to be, well, I'm going up 4 and I'm going across 4. So therefore it's 1. Now, if it didn't say what to do, further maths exam, clearly differentiate, which gives me 2x minus 1. Put in x equals 1 and I get 2 minus 1, which is also 1. So either way, I get 1. I suspect, like I say, this would be an on the graph question. Next question, simultaneous equations. Right, let's do this one carefully. Quick look before I jump in. It looks like z's are the best thing to do here, doesn't it? So label as ever, so 1, 2, 3. And then calculator out and ready. Now, again, in an exam, it would say solve, showing or working, because you can put this in your calculator. So I'm going to start by doing 1 plus 3, because therefore that will cancel the z's. So 6 and 4 is 10. 8 and minus 4 is plus 4y. And 750 plus 800, 100 is 850. Wow. Okay. I'm hoping this gets better. Then I'm going to do, well, let's do the same thing again. So let's do equation 2. Oh, sorry, no, 2 times equation 1, get it right, is going to give me 12x plus 16y minus 4z equals 1500. And then I'm just going to write equation 2 underneath, which is going to be 18x minus 2y plus 4z is equal to 1100. Okay, so let's add these up. So that's going to give me 30x, 16 minus 2 is going to give me 14y. 4z's cancel out, and that is 2,600. Wow, what a number. And that's going to be B. Now, let's do A times 3, because we're going to get rid of the x's. So that's going to give me 30x. plus, what am I doing, 3, so 12y equals 850 times 3 is 2550. Yes, it is. Good, happy with that. And then b, well, this one, I could just write this down, can't I? That's going to be 30x plus 14y. This you need to be careful, you can read your own writing, equals 2,600. Now I can see already these numbers are going to get a lot better very quickly. So take them away. 30 minus 30 is 0. 12 minus 14 is minus 2y, and 2550 minus 2600 is going to be minus 50, which all of that, after all those big numbers, means that y is equal to 25. And let's put that back into equation A, the original one. So 10x, which I don't know what x is equal to 850 minus 4 times 25, which is 100, which is 750. Which means that x, well, at least similar sort of numbers, right? They're all 25. So x is equal to 75. And then all of that's back into, let's do equation 3. So 4x, so 75 times 2 is 150 times 4 is 300, minus 4 times y, which is 100, plus 2 times z that I don't know is equal to 100. Add 100 to both sides is 200, take away 300, so 2z is equal to minus 100, which means that z is equal to minus 50. Wow, what a question. I mean, the numbers there are so nice, I'm pretty sure I'm correct. But either way, that is today done. Good mix of questions today. That middle question I know people do not like, so make sure you're okay with that middle question. As ever, let me know how it went for you. Like, subscribe. See you tomorrow.